So Chicago was fun. I made a lot of new friends. Campus beautiful. Honestly, before coming into this course, I had no idea what molecular engineering is. So in this video, I'll briefly explain to you the concepts of molecular engineering and how the process goes. So what is engineering? Well, engineers use math and science to solve real-world problems that are concerning us right now at this moment. For example, global warming, renewable energy, everything else, medical science, everything. And they iterate through a process called the engineering design loop. So essentially, engineers identify a problem, they research about the problem, they find possible solutions, select one solution, discussing in a group, and they construct a design. They test and modify the design and present the design to their peers and obtain feedback. And then following the feedbacks, they redesign. And this process is usually iterated through, let's say, 2 or 3 times before the final product can be made. As for molecular engineering, it is applying the principles of engineering, but on a molecular level, which means it is a microscopic level. So, for example, clean water supplies, renewable energy, mitigating CO2 emissions, and everything else. So, at UChicago, there are 3 themes for molecular engineering: material science, immunoengineering, and quantum engineering. However, during this course I took at UChicago, we mostly focus on what's known as the dye-sensitized solar cell, or DSSC. So it's basically a type of solar cell that can take in light and which hits on dye molecules, actually dyes, and then that emits electrons, which contributes to the flow of electron and creating a current. So there are all the components of the solar cells serve different functions. You can definitely look that up on yourself. I'm not going to go into too much detail. So basically, the TCO glass permits light to enter the cells and allows for charge transport. The dye molecules collects photons and emits electrons, which goes into the semiconductor or titanium dioxide, allowing for electrons to be transferred. And after the electrons are transferred, they will come back into another TCO glass, which is then connected with a catalyst, or usually platinum in this case, that can use to be speeding up the reaction between redoxing species, for example, iodine and triiodine species, that can further complete the circuit and therefore creating a whole solar cell. So for some of you that took biology, this must sound familiar because the dye-sensitized solar cells work just like a plant, because dye molecules are essentially chlorophyll, which takes in light, and for chlorophylls, obviously, they take in light and convert that into glucose and water, supplying the plants. So that's actually correct, and this inspiration of dye-sensitized solar cells is actually from plants. But here's how molecular engineering is going to take part in this. Because we want to optimize the solar cell, we want to be able to engineer the dye molecules, allowing for optimal absorbance. Or here's the absorbance formula right here. And we would want that to have higher absorbance because we want to generate more electrons, creating a large current, being more efficient. So an ideal dye molecule should easily attach to titanium oxide because that's where it's going to conduct its electrons, and it can absorb a wide range of electromagnetic radiations, which is basically light. So in our lab at UChicago, we actually used N-cysteine, which is a dye molecule that can be commonly found in berries. So we use raspberry juice actually to create our solar panel. And obviously today, dye-sensitized solar cells is still a very, very new approach to absorbing solar energy, and it is not as efficient as silicon solar panels and everything else, but it is a very cheap and useful alternative to silicon solar panels, and that's why we're trying to research about it. And yeah, that should be it for this video. I hope this gave you a brief and clear introduction into what we do at molecular engineering at UChicago summer program, and I'll explain more details in the next videos about what we did in our lab, how the solar cell actually works, and more computer modeling about the dye molecules. Okay, thank you.